Let's recall that. So what I said in last lecture, that in normed spaces we have a notion of length. So we define the concept of length in normed spaces, but the major concept that is missing, very important notion that is missing, is the angle between two vectors. So in inner product spaces, we can define uh, the notion of uh, angles between two vector spaces. Okay, let's see again it. Suppose we have an inner product space X, inner product space, and we have two vectors, say X and Y in X. X and Y are said to be orthogonal to each other. X is, so we write it as X is perpendicular to Y if but we have the inner product of these two vectors is 0. So if you remember the concept of dot product, the definition of dot product and its properties, you know from your vector calculus of intermediate, you know when two vectors are perpendicular, their dot product is 0. So similar thing happened here. So let's see some examples of this. So that time in the last lecture itself, we have seen that the zero vector. So can anyone give me the any vector which is perpendicular to zero vector? A vector orthogonal to zero vector? Hello? Am I audible?
Yes, sir.
Yes, sir.
Can anyone tell me a vector which is orthogonal to zero?
Sir, inner product 0 के साथ 0 है for all x belongs to.
Every element is orthogonal to 0.
Oh, sorry. So this means for so all vectors in X, all vectors in X, including 0, okay? All vectors X in X are orthogonal to 0. So this can be easily seen from this fact that inner product is 0. Okay. So this means 0 is the vector which is orthogonal to itself. And there is no other vector. Why? Because if you take, suppose X is any vector, suppose X in X is a vector which is orthogonal to itself, then by definition this inner product is 0. But you know by definition this inner product, if this inner product is 0, this is if and only if X is 0. How do you see this? How do you see this? This inner product is nothing but norm of X square. And when you say that this is 0, norm is 0, it happens only when X is 0. Okay. Then last time we saw the Pythagoras theorem, you have seen it, and then we defined the orthogonal complement of a set. Let us recall that as well. So suppose we have a set E in a non-linear space, in an inner product space X. We set E per as all X in X such that X A equal to 0 for all A in E. Okay, if this, so this is the definition of E per, or which is called orthogonal complement of E. So let's see this in say in R2. R2 is in a productive space. Let's see this here. So take E. Suppose E equal to 1 comma 1. So this is in R2. Okay, this is the subset in R2. So let's see what is its orthogonal complement. So here is the point 1 comma 1. So can anyone tell me the what would be the E complement?
So 0 ही
Huh? So 0 is one element, but so here it is saying all those x in x which are perpendicular to this.
ऐसा करेंगे, ऐसे आर के एलिमेंट जो 1,1 के साथ परपेंडिकुलर हैं।
हाँ ऐसे आर जो वन हाँ ऐसे तो पहले देख लेते हैं 1,1 कैसा है 1,1 मीन इट इज नथिंग बट दिस वेक्टर okay so this is
Yes,
r
sir.
1,1 so what are the vectors all vectors which are perpendicular to this so this vector is perpendicular okay this vector whatever this vector is this is perpendicular to 1,1 correct let's see what are all those vectors so what you do x comma y in R2 such that x comma y comma 1,1 is 0 but you know by definition what is this product what is this tell me
x1
how how do you define x comma y comma 1,1 in a
Inner
product
products, inner product.
what is the definition so how did you define inner product in R2 so I said
पेयर
हाँ,
वाइज
हाँ,
ऐड हो जाएंगे ना, x,1 प्लस y,1 सर,
x comma 1
x into 1 प्लस
x into 1 plus
y into 1.
y into 1 so in R2 this is same as the dot product that you already know
Yes,
okay
sir.
so this is x plus 1 plus y dot 1 clear okay so from here since this is 0 so what we get is x plus y equal to 0 do you know what is this
x इक्वल टू माइनस वाई का ग्राफ बन जाएगा
क्या क्या बनेगा what is this
तो
हाँ सही बोले
लाइन
आप
तो x इक्वल टू माइनस वाई का ग्राफ बना देंगे सेकंड कोऑर्डिनेट में x इक्वल टू वाई का जो ग्राफ बनेगा
हाँ बहुत सही so this means so what are you getting here is you are getting this is your x plus y equal to 0 correct
यस सर
and what was your vector was
x इक्वल टू वाई
x equal so this is your vector x comma 1 comma 1 if you remember or if you observe the subspace the linear subspace generated by this vector will be what will be the subspace generated by this vector subspace spanned or generated by 1 comma 1 what is it So how do you find subspaces or subspace generated by some vector? What you do? You take, say, suppose we are given a set S, okay, say V1, V2, Vn, or any other subspace. It may be infinite subspace, infinite set. So the subspace generated by S is nothing but the linear set of all linear combination, which is summation alpha I Vi. Alpha I comes from K. Set of all linear combinations. So what is set of all linear combinations of 1 comma 1? This is nothing but alpha 1 comma 1, where alpha comes from, here alpha comes from R. Okay. What is this subspace? So when you multiply alpha, say 2 in this,
2
so it will be 2 comma 2. When you multiply 5, it will be 5 comma 5. And if you multiply by any alpha, that will be alpha comma alpha. So in this case, you are getting this line, this linear, this is the linear subspace. Okay, correct? Hello.
Yes, sir.
Yes, sir.
And what? So from here you can observe that this subspace. So say I'll write this as, okay, not like this. I will write. So this is nothing but span of 1 comma 1, and say this is E equal to span of 1 comma 1. So this, I don't say this. So E is 1 comma 1, and span of this is the subspace, uh, this subspace. Okay, and when we were finding the orthogonal complement of E, but we get a subspace. So we were given only a
सर
set E, which was 1 comma 1. हाँ
सर सर ये जो
हाँ,
आप
बोलिए
जो
बोलिए।
1,1 पेयर वाइज एलिमेंट ले रहे हैं R2 का, तो ये सर पर्टिकुलर आप ले रहे हैं जिसे हम कुछ जैसे मान लीजिए हमने 2,2 ले लिया, और उसके साथ देख रहे हैं कि ऐसे वेक्टर R2 के जो 0 दे रहे हैं, मतलब तो सर आप पर्टिकुलर एलिमेंट के साथ ऐसा कर रहे हैं यहाँ पे?
तो मैं एक एग्जांपल ले रहा हूँ। देखो, हमने एक डेफिनेशन दी, ये डेफिनेशन थी,
हाँ, डेफिनेशन दी आपने, एक
ठीक है।
पर्टिकुलर आपने एलिमेंट
एक
1,1
एक
उठा
एक
लिया R2 से।
एक एग्जांपल लिया, एक सेट लिया, ठीक है। अब
हाँ,
हम इसका ऑर्थोगोनल कॉम्प्लीमेंट देख रहे हैं। अब हम उस ऑर्थोगोनल कॉम्प्लीमेंट के बारे में कुछ बात कर रहे हैं। आप इस ई की जगह आप मुझे कोई दूसरा सेट दे सकते थे,
2,2
ठीक है।
हो गया, जैसे
हाँ,
1,2
मीन्स
हो
कोई
गया,
भी,
कुछ भी ले सकते हैं।
और
कोई,
अगर मैं
ये केवल
ऐसा ए
एग्जांपल के लिए है।
यस सर।
हाँ बोलिए, हाँ बोलिए, और कोई कुछ बोल रहा है?
मैं कह रही हूँ, अगर हमारे पास सिंपली ए भी होता और हमें पता नहीं होता कि वो पॉइंट्स क्या हैं, तो हम उसको कैसे डिफाइन करते हैं?
प्लॉट करते सर
ए बी
उसको।
होता तो हमें तब भी पता चलता है। हाँ, तो देखें, ओके। सो ई इक्वल टू ए कॉमा बी, this is a comma b equal to a comma b. Okay, so let's do that. So what is e perp? E perp will be all those points
कॉमा ए बी
x comma y in x, means here x is R2, okay, such that a plus yb equal to 0. Why? Because this x comma y comma a comma b equal to 0. So this is ax plus by equal to 0. You know this is a line.
यस सर।
Okay. Ax equal to by, ax plus by equal to 0 is a line which passes
यस
through origin and some point. So it passes through this point and say 0 comma 0 comma 0 comma okay, if x is 0, then if x is 1, then
Y is equal
if
to
x is 1, then y
A.
equal to minus a by b. Okay, it passes through these 2 points, and so if you have a line in R2, okay, and it passes through 2 points, means you exactly know what that line will be. Correct? If you have an arbitrary point, arbitrary vector, you know what is the orthogonal complement of that vector. So if you see what is this geometrically, so this was R2, so this was A comma B, and you are getting AX plus BY is something like this. Okay, and your was, so this point was AB, not this point. This is the point AB. Okay, if this is the point AB, then AX plus BY is this. Correct? Say if AB is 1, 2, then AX plus BY will be the line X plus 2y equal to 0. And you know it, so you know how to draw this line. So see,
Yes, sir.
whenever you have a vector, you are getting this E perp as a subspace. E perp is a subspace. This is a subspace of X. Correct? And here something is called complement. So if you see the definition, it is orthogonal complement of it. Why is it complement? Because you will see later. You will see later that when you when you 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 when you do this thing, when you take a span of E perp and this set E, you will get whole of X. You will get X. How? See from our example 1, 1 and this another set, another E perp. So here E was 1, 1, and this is your E perp. Okay. So what is the span of E perp and E, where E is what is the span of this if E equal to 1, 1. So how do you define span of E perp? Span of A comma B? Span of A comma B is nothing but all
Alpha I.
or some alpha, right, alpha I AI plus beta I, say alpha A comma alpha A plus beta B, alpha A plus beta B, where A belongs to A, B belongs to B, alpha beta belongs to K. Okay, so take any element xy in R2. So claim is xy can be written as a linear combination of an element from E perp and E. Okay, so E was 1, 1, correct? So and take any element. So take an element from E perp, say 1, minus 1 is one element. If you see here, 1, minus 1 is one element. Okay, so you can write this xy in this as a linear combination of these two elements. So can anyone tell how can we write this? So alpha plus beta equal to x, and alpha minus beta equal to y. So what would be alpha plus alpha and beta? You can find from here. So this is 2 alpha equal to x plus y. So alpha is x plus y by 2, and similarly beta is x minus y by 2. So when you make this calculation, x plus y by 2 1 comma 1 plus x minus y by 2 1 comma minus 1. So you will get x comma y. So this is x plus y by 2 plus x minus y by 2, x plus y by 2 minus x minus y by 2. Okay, so from here this y get cancelled, 2x by 2 is x, and from here x and x will get cancelled, this minus minus will be positive, y by 2 plus y by 2 is y. Okay, so any element can uniquely be expressed as a linear combination of E and an element from E perp. Therefore, since we are getting from E and E perp the whole of X, so therefore the word complement. So this is orthogonal complement. Okay, so which completes X. Okay, so there are some observations. So let's see this observation. If you have two sets, A and B are subsets of X, and B A is subset of B, okay, then there is a relation between A perp and B perp. So claim is uh, what it should be. Any guess? If you have two sets, two subsets of X, A and B, and one of them is a subset of other, say A is subset of B, then what is the relation between A perp and B perp?
B perp is
B
the
perp
subset of A perp.
Okay, how?
Mm,
How do you see this? So for that, choose any element in B perp. Okay. Now you have to define U belongs to A perp as well. So what is the meaning of this thing? This thing means U comma B is 0. This inner product is 0 for all B in B. Okay. But you know, since A is a subset of B, in particular U comma A is 0 for all A in A, because this A is a subset of B. This A already sits in B. Okay, do you see this?
Yes.
A always sits in B. Therefore, from this fact, U comma A is 0. Okay, this means U is in A perp. So whatever element you are taking in B perp, you are getting that element in A perp as well. Do you see this? Okay,
Sir.
so okay, let's see another thing, one very important thing. So from our example, again that example, we define, so we took a set E, then we get E perp, which is a subspace given by this set X plus Y equal to 0. Okay, then what would be E perp of E perp? What would be the perp of E perp? So E perp. So we will write this as What is this? Can anyone tell? Hmm?
सर एक एलिमेंट ही पर से लेंगे पहले
हाँ ओके so हमें मालूम है ई पर में किस फॉर्म के हैं x plus y equal to 0 correct so what will be e per so this will be all those alpha comma beta in R such that alpha beta inner product with x comma y equal to 0 whenever this x comma this is true for all x y in e per but there is a relation between so there is so from here what you get is x plus y equal to 0 this means x equal to minus y correct so what you are getting here is alpha comma beta x comma minus x okay
Yes, sir.
it's 0 oh, but I'm writing
Alpha x beta minus x.
1 minute. This is 0 so this is alpha x minus beta x equal to 0 so from here x alpha minus beta is 0 okay
If x
correct
non-zero,
so and this is true for all x in k but you know x for non-zero x when x is non-zero this is true so this means alpha minus beta equal to 0 this means this is alpha equal to beta so what is the set e perp then this is alpha comma alpha where alpha comes from k and you all know what this set is what this subspace is okay so this subspace is nothing but this line x plus x minus y equal to 0 okay so in other words this alpha comma alpha is the subspace generated by 1 comma 1 this is span of 1 comma 1 do you see this
yes sir.
okay
परपेंडिकुलर ही हो जाएगा ना अपने ई के
हाँ
सॉरी
हाँ ई पर के है ना
और ई पैरेलल हो जाएगा यानी कि कोइंसाइड कर जाएगा बस स्पैन हो जाएगा उस पर ही
हाँ उसका स्पैन हो गया okay so let's see a result uh, okay this was about orthogonal thing so you all know now what is orthogonal set and what is orthogonal so sorry what is orthogonal complement of a set A or a set E okay then in your notes there is a result which says you have a subspace and you have two orthogonal closed subspaces of H okay then M plus so this is a Hilbert space you all know what is a Hilbert space what a Hilbert space is a Hilbert space is a complete inner
प्रोडक्ट स्पेस
product space so H is a so if H is complete inner product space then it is a Hilbert space M and N are orthogonal closed subspaces of H, then M plus N is a closed subspace of H. So you all know how do we see this. So say we are in R3. So in R2 it is easy to see. Say let's see we are in R3. Okay. So you know R3 is a complete inner product space, hence it is a Hilbert space. And take two closed subspaces of R3. So take two. So suppose this line passing through origin is a subspace and another line another line. Okay. So say it comes like this and it goes, it penetrates this paper. Suppose we have these two subspaces, both are closed subspaces. How do you see this? These are closed. So in so this is finite dimensional space. R3 is finite dimensional space, and so it is easy to see that these you have already seen this. So these subspaces are closed subspaces. Okay, then what is the M plus N? So this is say M, this is N. What would be the M plus N? M plus N is nothing but all linear combinations of elements coming from M and N. So this is alpha M plus beta N, where alpha beta both belong to the field, whatever the field is. Here in R3 this is R, and M comes from capital M and small n comes from small n. Okay, this is M plus N, correct? So we want to, so if you see M is a subspace, say in this example M is spanned by um, some vector, say x1, x2, x3, and this N is again linear subspace of dimension 1 in R3. It is spanned by a vector y1, y2, y3. Okay, correct? So then what would be M plus N? You know what that is. So any element coming from this subspace spanned by x1, x2, x3 is of this form: alpha x1, x2, x3, and you are multiplying that by some scalar, say a. Okay, let me write this. Any vector in the subspace spanned by x1, x2, x3 is of this form: a x1, x2, x3. Correct? Any vector coming from subspace spanned by y1, y2, y3 is of the form b y1, y2, y3, where b is a scalar and a is a scalar from R. Okay, so how did we define M plus N? M plus N is you multiply this by alpha, you multiply this by beta, and add this. And here alpha, beta, A, B, these are all real numbers. So if you see this, so it is nothing but say gamma 1, where gamma 1 is alpha A, gamma 2 is beta B. This is of this form: gamma 1 x1, x2, x3 plus gamma 2 y1, y2, y3. Okay, And you know this is a plane in R3. So when you sum these two subspaces, you are getting a plane in R3. And passing that plane passes through the origin, because this 0, 0, 0 is both, this belongs to both M and N. So when x1, x2, x3, so when gamma 1 is 0, it is 0, 0, 0. When gamma 2 is 0, it is 0, 0, 0. So a plane which passes through the origin and which contains the line M and N. That is the subspace M plus N. Okay. And it is easy to see this is closed subspace. Let's see a proof of this. So for proving closeness, what we will prove is wait a minute. Okay, wait a minute. Let's see proof of this. So for proving this, what we do, we will, so a subspace is closed if its closure is itself. So we have to prove M plus N bar is M plus N. Okay. So H is, so we will use few things. So so I'm giving you the idea of the proof. So I'm not writing the whole proof. What is the idea? So you all know M and N are both closed. M and N are closed. Okay. And H is complete. So this means M and N both are complete. Both are complete. Complete spaces, complete inner product spaces. Okay. Subspaces. So what you do, you have, so it is always true, M plus N is a subset of M plus N bar. It is always true. So what we will prove, we will prove M plus N bar is subset of M plus N. So take any element from plus N, say X, say any element Z in M plus N bar. So by definition of closure, there exists a sequence Zn in M plus N such that Zn converges to Z. But Zn is in M plus N for all N. So this means Zn can be written as a sum of two elements coming from M and coming from N. Okay, say Xn comes from M, Yn comes from N. Yn from M, Yn from N. Now use, okay, use properties of inner product spaces. You have seen that when two things are perpendicular, then you have Pythagoras theorem. Use that theorem and you see, prove that uh, Xn and Yn are Cauchy sequences in M and N. Okay, how do you see this? You seeing this is easy because Zn being a convergent sequence, Zn converges to Z. So if we convergent sequence is Cauchy sequence. So using properties of inner product space and Zn is a Cauchy sequence, prove that Xn, Yn both are Cauchy sequence. And since M and N are closed in a complete inner product space, therefore they are complete. So by the definition of complete space, if the Cauchy sequence is convergent, so Xn converges to some point, say X, Yn converges to Y, you will get this. And from Zn converges to Z, where Zn equal to Xn plus Yn. And from here, you are seeing that Xn converges to X, Yn converges to Y. You will get this X plus Y in M plus N. So what you have proven is, so you took an arbitrary element Z in M plus N bar, where Z is nothing but, okay, and you will say that since Zn is convergent and it converges to Z, so this limit is unique, so therefore this Z would be X plus Y. So from here you took a, so you started with an arbitrary element in M plus N bar, and you have shown that this to Z, this Z belongs to M plus N. This means M plus N bar is a subset of M plus N, and you are done. So I am skipping this. Please do it your own. Let us now ask another question. The question is this. So suppose we have a subset in R2, say this is the subset in R2. This is clearly convex set. Okay, so you all know what a convex set is. So now question is, given a point X in R2 and given this set, convex set, say this is E. Okay, so what is the distance of E from X? So you know what it would be, and say this is the distance. Suppose this is the distance. So how do you define distance? Dx comma E. How do you define this? This is infimum of dxa, where A runs in E. Correct? So question is there exists A, is there exists some A naught in E such that dx A naught is this distance? Say suppose this is delta, this suppose, okay, suppose this is delta, then is there exists some point A naught in E such that dx A naught equal to delta? Okay, so let's see, in some cases is A naught exist or not, or then we may ask whether this A naught is unique. Okay, let's see some examples in R2. Okay, we have this R2 and we have an open segment, open line segment. Say this is an open line segment. What is this set? Suppose we are taking this as, say this is 0, 1, and this point is say minus 2, 0, and this point is say 1.5, 0. Okay, now take this set this red, say red line segment is nothing but this set, say this is E equal to 0, 1 cross, okay, so I will not write like this, I should write this is as minus 2, 1.5 cross 1. Okay, this is the set. Now, and don't write open line segment. So say this is open. Open means the endpoint does not belong to the set. Does not belong to the set. So now we take this as a point X, and we want a distance from X to the set E, and you know what that would be. It would be the distance between the this is uh, this D is the distance between X and the set E. But you know there does not exist any point in E such that this D is attained. Okay. Wait for a minute. Okay. So okay. So so this is the distance, but there does not exist any point in E such that this D equal to distance between X comma A naught. So this means no E naught exists here. Okay, no A naught exists in this case such that D equal to this part. Second thing, the same take the set E equal to now take close 1.5 comma 1. Okay, now take equal to the same thing but with endpoints. Same thing with endpoints. So endpoints are there. These 2 points belongs to the set E. In this case, in this case, there exists X naught, there exists A naught, which what is A naught? A naught then? A naught is this point minus 2 comma 1, minus 2 comma 1. If minus this is minus 2, this comma 0, this is 0 comma 1, this point will be minus 2 comma 1. And when x, my x is here, if this is x, then and this distance is d, then a naught d equal to distance between x comma a naught. So in this case there exists a point. Okay, and here it was in these two examples. So in one case a naught does not exist, in second case a naught exists and it is unique. Let's see a third case. See this. Okay, and oh sorry. Take this arc. Okay, say this is circular arc. Suppose this is circular arc. It's exactly so. In my figure, it is not looking like a circular arc. Assume that it is circular, and say this is the center. You all know by the property of circle, distance from the center to any point in the curve will be same, always same. So for this set, say suppose this is set E, this circular arc is the set E, and this is the center is the point X, then you have many points. So there exist many points in there exists more than one point in E such that d of xe equal to dxa, there exists more than one point. Okay, so there are, in fact, there are infinitely many points such that this distance is dxa, say, okay, say dxa1, dxa2, there are a1, so this is a1, this is a2. So in this case, the point is not unique. Here is our, so we were interested in the problem number first, whether there exists an element, a vector in E such that this, at that point, this infimum is attained. And second question was whether that that point is unique or not. So here is our result is minimizing vector theorem. Okay, so let's write, let X be an inner product space and M is a non-empty subset of X and it's convex. M non-empty be a convex subset of X. Convex, and one more thing, M should be complete. M is convex and complete subset of. Let me write it. M is complete. Then the conclusion is, for every given X in X, there exists a unique Y in M such that this infimum will attain there.
ये लास्ट वाला जो एग्जांपल है वो थोड़ा समझ नहीं आया।
कौन सा? ये लास्ट एग्जांपल।
यस सर।
यहाँ पर क्या लिया मैंने, एक सेट लिया, एक सर्कुलर आर्क लिया ऐसा, ठीक है, सर्कल बनाया और उसका एक आर्क ले लिया, करेक्ट।
यस सर।
इसको मैंने ई लिया और इसके जो सर्कल का जो सेंटर है उसको मैंने पॉइंट एक्स लिया, ठीक है। मेरा क्वेश्चन था कि एक्स से ए की डिस्टेंस क्या होनी चाहिए। आपको प्रॉपर्टी मालूम है एक्स की, ये डिस्टेंस कितनी होनी चाहिए, रेडियस के बराबर होनी चाहिए, आर व्हाटएवर रेडियस of that circle is, it will be the distance between x and the set E, correct? होगा या नहीं होगा?
Yes sir.
And you know there, so if E is a circle, the distance from the center to any point in this circle will always same. सर्कल की डिस्टेंस सेंटर से हर एक सर्कल के हर एक पॉइंट पर हमेशा सेम होती है।
Yes sir.
और वो रेडियस के बराबर होती है। तो मैं कह रहा था कि मुझे बहुत इनफाइनाइटली मेनी पॉइंट मींस ई के सारे पॉइंट ऐसे पॉइंट हैं जिनकी डिस्टेंस एक्स से सेम है, हमेशा बराबर। ओके, सो दिस मींस दिस, इफ आई टेक डी इक्वल टू इंफिमम ऑफ मॉडुलस एक्स कॉमा मॉडुलस, ओके, इसको मैं ऐसे नहीं लिखता हूँ, इसको मैं लिख देता हूँ dx comma a, where a in E. So you see this infimum attains at each point, at every point of E. So there are many points, more than one point. So question was whether that point is unique or not. Okay, in this case, so there were two questions. Number one, existence. Number two, uniqueness. So first one is there exists a point where infimum attains. Second was whether that point is unique or not. So in this case, existence is there exists a point, and second case, that point is not unique. In first case, existence is not there. There does not exist any point. So uniqueness की फिर बात ही नहीं आई. Okay.
Okay, sir.
In second case, it was there exists a point, but it is unique as well. थर्ड केस में क्या है कि ये थर्ड केस हमें मिल रहा है कि हमारे पास एक सेट तो है, सेट में सॉरी वो डिस्टेंस एग्जिस्ट कर रही है, मतलब पॉइंट एग्जिस्ट कर रहे हैं और वो बहुत सारे पॉइंट पर डिस्टेंस आ रही है ना.
Sir, okay.
इन्फिमम अटेन हो रहा है बहुत सारे पॉइंट पर. एंड इफ यू सी दिस इज नॉट a convex set. If you take this point and this point, the line joining these 2 points does not belong to E. Okay, so this set is not unique. अभी ऊपर जो हमने मिनिमाइजिंग वेक्टर थ्योरम लिखा है वो क्या है, हमारे पास एक इनर प्रोडक्ट स्पेस है, एक M कॉन्वेक्स सबसेट है, साथ में कंप्लीट है. तो किसी भी कोई भी पॉइंट अगर x दिया हुआ है तो हमें एक यूनिक y मिलेगा जहां पर ये कंडीशन सेटिस्फाई होगी. And this is equal to norm x minus y. So this is nothing but distance of x and M, and this is the point, this is distance of x comma y. You all know this. So if the norm gives a metric, and this is the definition of that metric. Correct? Okay, we will see a proof of this. Or please, I have written its proof. So please read it, and if you have any doubt, then we will discuss it. Okay? Okay, drop your attendance. Any question or doubt? Hello? Any question, comment, doubt? Okay, if not, then bye.